Here I have a quadratic with roots of -2 and 5. Here I've got a different quadratic with roots that are both 1 less. I've just subtracted 1 from each of those roots. Let's see what effect that has on the equations of those quadratics. So for the first quadratic, because it's got a root of -2, I know that it's got a factor of x plus 2. Because it's got a root of 5, I know it has a factor of x minus 5. And I know timesing those factors together gives me the quadratic equation of those of that curve. Right, let's do the same thing with the second equation, where both of the roots were 1 less than what I started with. So the fact that we've got a -3 there means I've got x plus 3 as a factor. The 4 means I've got x minus 4 as a factor. And multiplying those two equations, multiplying those two factors together, gives me the quadratic associated there. So this quadratic has roots that are 1 less than this quadratic. But what this video is all about is how can I go from one quadratic to the other without finding the roots themselves. We're not allowed to actually find the roots. We just have to use the graph transformation of the roots to transform the equation itself. So I'm going to do 2 examples. The first one is actually the exact same question we did a moment ago. Same quadratic look, x squared minus 3x minus 10, but we're going to do it without finding the roots. So first thing I'm going to do is think carefully about what alpha and beta are. So alpha and beta, they were the roots of this original equation. So they are x values. This alpha minus 1 and beta minus 1, they're roots of a different equation that I need to find. Now, I can call that equation, I can use any variable I want for that equation. I've used w. You can use whatever you want, doesn't matter. So, my w has roots that are alpha minus 1 and beta minus 1. But I know that the alpha is an x value, and the beta is an x value. So therefore I know that w is equal to x minus 1. My w here is equal to x minus 1. X minus 1. Which then allows me to rearrange this equation to make x the subject. Which then means that I can substitute this w plus 1 in here and here. And then expand the brackets and simplify to get my equation in w. So this is the equation in w that has roots that are 1 less than the roots of the original equation. Notice that that is the exact same equation as I've got here. I've just used the variable w instead of x. My second example for this video, and a much more complicated one, because we've got a quartic equation now. X to the power 4 minus 12x cubed plus 52x squared minus 100x plus 75 is equal to 0. And that's got roots of alpha, beta, gamma, delta. I want to find the equation that have got roots of 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, and 2 delta plus 1. So each of the roots should be 2 times bigger plus 1. First thing I've done, the alpha, beta, gamma, delta, they are all x roots. I'm going to find an equation in y, so I've called my y roots as 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, 2 delta plus 1. So each of my y roots is 2 times the x roots plus 1. And I've now rearranged that to make x the subject, so I've subtracted 1 and divided both sides by 2. Which means that I can now substitute this y minus 1 over 2 instead of the x here, 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 here. And now we're going to expand these brackets and simplify, and we're going to do it really carefully. So you first notice that I haven't actually expanded any brackets on the numerator yet. My first thought here is simplifying the fractions. So I've just done the 2 to the power 4 is 16, and the numerator, I've just left that as y minus 1 to the power 4. Let's not overcomplicate this, let's just do one thing at a time. So let's just deal with the fractions first. I've got my 2 cubed here, and then I've got the y minus 1 cubed on the top. I've got my 2 squared here, and then I've got my y minus 1 squared on top. And then here I've just got the 2 to the power 1. Right, now I can see how I can simplify all of these fractions. If I times through by 16, it's going to simplify each of these terms here. So that's my next thing. I'm going to times through by 16. So if I times this by 16, the 16 cancels out. If I times this bit by 16, well, the 16 divided by 8 is 2. So actually, I'm just going to times the numerator by 2. If I times this thing by 16, well, the 16 divided by 4 is 4. So actually, I'm just going to times the numerator by 4. Times this by 16, the 16 divided by 2 is 8. So I'm just going to times the numerator by 8. And then I've got the 75 times 16 and the 0 times 16. Right, at this stage here, we've managed to get rid of all of those fractions. So now we can just focus on expanding those brackets really carefully. So the y minus 1 to the power 4. So y minus 1 times y minus 1 times y minus 1 times y minus 1. Expand out those brackets, or use the binomial formula if you know that. And we will get this. Then we're going to expand out the y minus 1 cubed. So y minus 1 times y minus 1 times y minus 1. Or again, use the binomial formula if you know that yet. And we get this. Y minus 1 squared is this. Over here then we've got the minus 800y. And we've got the minus 800 times minus 1. Then we're going to times all of this by the minus 24. We're going to times all of this by the 208. And then at the end, we're going to collect up the like terms. We've got the y cubed terms there. We've got the y squared terms there. Then we have got the y terms there. And then we've got the numbers there. And there we go. That is the equation that has got the roots that are all 2 times bigger plus 1 than the original quartic equation. And we can double check that if we want. You can check this on your calculator. If you go to the quartic solver, the polynomial solver, select degree 4. The original equation had coefficients of 1, minus 12, 52, minus 175. And if we solve that equation, we get the roots of 5, 3, 2 plus I, and 2 minus I. The second transformed equation had coefficients of 1, minus 28, 286, minus 1,292, and 2,233. If you solve that equation, you find that the roots are 11, 7, 5 plus 2i, and 5 minus 2i. And just compare those two roots. Oh, it's annoying, it's not letting me do this. But look, we've got 5. We've got 11. The 11 is 2 times 5 plus 1. We've got 3 and we've got 7. The 7 is 2 times 3 plus 1. We've got 2 plus I. If I times that by 2 and then add 1, I get 5 plus 2i. So we can see here how the roots of the transformed equation are 2 times the roots of the original equation plus 1. So just to repeat your method here then, you're comparing the alpha, beta, gamma, delta and the transformed alpha, beta, gamma, delta, coming up with the equation that links the variables to the original variable, rearrange to make x a subject, substitute it into the equation and then expand and simplify until you get your new polynomial.